I'll first show you how it's working or what it does before telling some more about it. So the basic idea is you have
it's okay.
green shirt in this case. The computer only knows it's a green shirt. It knows there's some structure on it, does not know what structure. So that the only requirement here is to have a green shirt, in this case with some structure, and the system can recognize and then replace the logo on the texture. And if you look closely, you can also see that the shadows are reconstructed, and that you get all the deformation of the shirt into the rendering. So, and of course you can customize the colors, you can customize the logos. And actually, when you put it on, you can pretty much really move in front of the system and look how the t-shirt would fit you. And to give you some background information, we did the whole thing actually for Adidas for shoes. We did it for their flagship stores in, I think in Paris it was, and I think they had one in London, but I'm not sure. And the idea was they had shoes, you could fully customize, you could put your name on it, you can combine different textures, different colors and all that stuff. The problem is the client wants to try the shoes. They had dummy shoes in different sizes, so the blow estimator could try the physical fit, but they could not see how it looks, and most people weren't really satisfied. So they could customize the shoe, they could order it, and they get it 4 weeks later, but they could not see how it would look on the foot. So actually this was this system which is running currently. So the customer could customize on the top screen, and then he could stand in front of the system and turn his feet, and he would see an augmented version of the pre-produced shoe, if you like, the original shoe, on top of his foot. And this is easier for shoes because they're rigid object. It's very easy to follow in the video for the computer. And we extended the whole system to do it also for non-rigid objects like shirts. And of course you could think using this technology also for glasses or for jewelry or whatever for web shopping.
It's not using the pattern there?
It's using any pattern. It's just important to have a green, which is just a chroma key. Green is not a color many people wear, so it's easy to detect in the image. And then it's just important to have any structure on the shirt.
So it's just a 2D image.
It's a 2D image. But the shoe was 3D, so you always have to do a trade-off between rigid 3D or non-rigid 2D. Because, I mean, you cannot learn a model from a shirt because you can crumple it and it's so
Is that?
Oh, and one funny thing maybe to conclude the presentation. You would not buy such a shirt, but could at least visualize it. Maybe in some years. Okay. Any questions?
So is that the 3D surface tracking or what? I mean, is that tracking?
It's a 2D tracking in this case. In this case it was a 3D model-based tracking.
3D model-based tracking.
Like 2D surface tracking.
Yes, 2D tracking. Okay, but you can model the shadows, the textures, and in real time. I mean.
Maybe one more thing. The whole system is using only a single camera. That's
this
the reason
is
why it's 2D tracking in this case. Which is quite different, for example, from the virtual eye contact, where you have 3 cameras to do 3D reconstruction. We only need a single, pretty cheap camera, and only a single consumer PC. So it looks huge, the whole system. Although the sky's the secret, but it's only actually enormous PC, so it's not much in there. And actually, you could probably do it today with such a computer like a Mac Mini or something.
What are some commercial applications that depend on that?
For example, for Adidas, it was one. Of course, you could think about web shopping, like a customer account has a webcam, and you can go to a web shop and try on glasses, jewelry, or stuff like that. So this would be actually one possible application.
But the customer needs a master, like a green shirt or green glasses, or?
Yes. In this case, yes. The shoe system, actually, the shoe does not look really different from another one. So for the shoe system, you could wear your shoes as long as it's not too. I don't know. Of course, a high heel would not work for sport shoes, but for generic shoes, you could step in with your own shoes and it would work. For a t-shirt, it's just important to know, for the system to know what it's looking for. So we choose to have a green one, it's easy to detect, and the structure on the shirt does not matter. It could be anything.
Presumably it would be easier to adapt it for trousers or gloves or something else. It would be easier to adapt the system for, say, trousers or gloves or something like
I
that.
would not say easy, but it's possible.
So that, for example, if the user has its own glasses or USB and he would like to buy a new model or like for example from somewhere,